Hello and welcome. I have another solver related problem here. So we're putting ourselves in the position of a portfolio manager in charge of a bank portfolio that has $10 million to invest. And this specific manager is trying to allocate this $10 million across 5 different bonds. And what we need to do is to figure out how much of this 10 million to allocate to each bond to optimize the portfolio's return given the restrictions that the bank places on their portfolio managers. For example, municipal bonds must not total more than 3 million. The average quality cannot exceed 1.4, given the bank's rating scale on quality, where a lower number is better. And then the average years to maturity must not exceed 5. So how to allocate this $10 million amongst these 5 bonds to optimize earnings, given these 3 restrictions? So to solve this, what I'm going to do is I'm just going to start by copying and pasting this data. I actually don't need this Moody's rating here, so I'll delete it, but I do need these other ones. Okay. To start off the setup, what I'm going to do is create a column called amount to invest right here. This is the dollar amount we're going to allocate to each bond. And this is what I want Excel to calculate for me. So I'm going to leave this blank for right now. However, I do have to do part of the setup still to this column. I want to know, I have $10 million to invest. So I need to calculate what the total is going to be. That's what this is here, is going to represent. So if I have $2 million per bond to allocate that 10 million, this would be the 10 million showing right here, the sum. But I'm going to just leave that as it is for right now. Again, I want Excel to calculate this for me. Municipal bonds, our first restriction here is municipal bonds must not total more than $3 million. There's these 2 municipal bonds here, A and E, and the combined value of those 2 must be less than or equal to 3 million. So we need to have a total calculation for the amount we've allocated to municipal bonds. And I could do a sum if, or I could just do this one plus that one, whatever is your preference. In this case, I'm not going to be copying and pasting this formula. So since I'm not copying and pasting it, I don't really need to do a sum if, but I could. All right, so I've got this value here. I've got this calculation that will be able to tell it do not exceed $3 million. The average quality of the bond cannot exceed 1.4. So the average cannot exceed 1.4, the average quality. Now, you might be tempted to use some sort of an average function here in order to do this. It's tempting to think that way, yes, because there is a built-in average function. However, the average function in Excel is the sum divided by the count of something. Here, that would be inappropriate because what we're trying to do is a weighted average, or what we need rather is a weighted average, which is slightly different. So I need to have a weighted average calculation, and I'm going to add that here. I'll call it average quality. To do the average quality, I take the amount, multiply it by the quality, and divide it by the total investment. And basically, I should have made this row reference absolute. Basically, you need to copy and paste this down, and then the average for the portfolio is the sum of each of these. And I did it this way for a specific reason. Alternatively, what you could say is this specific bond comprises whatever this is, 25% of the portfolio here, and then multiplied by the rating. And then if we structure this properly, it should yield the same value here and here. It's the same overall weighted average. But because it's just multiplication and division, the order of operations, it just doesn't matter. So I took amount multiplied by rate and divided it by the average quality. The amount invested. Okay, so we have this average quality calculation, but I'll delete these. Right, and I get this divided by zero error if these are blank. This is actually going to become problematic in Solver, so I won't be able to use this. I'll show you why when we get there. Okay, so we at least do have a calculation for average quality. Let's do the same thing, average years to maturity. And since it's the same calculation, I'm just going to copy and paste it, over. And double click and update my references. These ones and these ones. Maybe I should have made the column references absolute before, but I didn't think of it. And we are where we are now. Okay. So I've gotten at least some test right now for all of these restrictions. I need to calculate now one more thing, my after-tax earnings. So I need to have like my objective cell calculated, total earnings. If I invest a certain amount in this bond, and that yields 8.6% after tax, that would be my earnings. So I can kind of go through this just like this. This is a very inefficient way of going about it, but there's only 5 rows. So it won't be too time consuming. A more direct approach, I'll just do this, and we'll see what the total earnings are just by putting in some sample values in a moment. So I'll say like 1 million here and 1 million here. My earnings are 104,000. A more direct approach would be using what's called the sum product function. I'm going to take like this is my array 1, this is my array 2, and I'm going to say like this multiplied by that plus that multiplied by that. And this is the sum product function. I should get the same value. Okay, so either of these become my objective function here. I want to maximize my total earnings associated with my portfolio by allocating $10 million here. Let's now go into Solver. All right. So in my Solver parameters dialog, I have to set what my objective is. We just went over this. My objective is to maximize my total earnings. So I select the cell where I'm calculating total earnings and I specify it to a maximum value. What I'm changing here is the amount to invest within each bond. We have our 3 constraints we've discussed. My first one here is that my average quality must be less than or equal to 1.4. Add. My average years to maturity must be less than or equal to 5. That was constraint number 3. My total municipal bonds must be less than or equal to 3 million. And I haven't yet put in how much money I have to invest. The amount to invest must be equal to 10 million. Okay. So I'm going to click on solve. I don't think it's going to work though. We'll see. Maybe it will. It did not work. Okay, I'm going to go back and I'm going to delete the constraint related to both quality and the constraint related to years to maturity. So I'll delete that and I'll delete that. The reason, I should have maybe left it in there to describe. I'm going to add one back in. That's my bad. It's going to say this must be less than or equal to 1.5. And I'll try to solve it. This dialog comes up. It encountered an error in the objective or constraint. And it says one of the cells in the worksheet became an error value when Solver tried certain values for the variable cells. Okay, so one of the formulas I created produced an error. So I'm going to delete this and close out of my model. Remember when I first did this weighted average calculation? I get a divided by 0 error because this is actually producing a 0 total investment right now. So when it's iterating through, values before it gets to the constraint, it's actually like producing an error in my formula. And I actually can't have an error in my formula before I go into solver. Um, so this is what this is doing here. So we actually need to think of a creative way around this so my weighted average calculation will not produce an error in any possible iteration. So let's think about this here. What's another way of going around this? Let me think about this. Average quality here must be less than 1.4. This formula here that I have is amount times bank rating divided by total investment must be less than 1.4. So what I can maybe do is structure this like inequality a little bit differently. I have amount invested times bank rating, maybe amount times bank rating must be less than or equal to 1.4 times total investment. Is maybe another way of going about this, and it's going to be the kind of the same approach for yield to maturity. Instead of actually calculating what the weighted average is, I'm going to calculate, express it differently. So I'm not doing any divided by 0 at all. So here I'm going to say amount times, this time YTM, is less than 5 times my total investment. So I'm just restructuring the calculation. And I'm going to have to do that somewhere here. To do that, I'll have to have, maybe I'll do it down here, quality. I'm going to actually reuse that YTM, or sorry, sum product calculation I did before, where I did my amount, and I'm going to multiply it by the bank rating here, which is sum product. And if I divide this by my total amount invested, this will be a complete duplicate of my average quality here. So even before I get to this, I'm just going to put in some values here. So this average quality and this average quality are equivalent. However, I'm going to structure this in such a way where it is not equivalent. I'm going to get rid of my division sign here. I'm just going to do the sum product of it. And over here, what I'm going to do is my 1.4 times this amount invested. And then I'm going to do the same thing for YTM. It's the sum product, but this time of the YTM column. And this time it's not 1.4 times. My criteria is 5. So now if I go into solver, my constraint becomes this quality has to be less than or equal to this value. And my constraint for YTM has to be less than or equal to this value. Okay. I'm going to click on solve now and see if this can go through it. I found a solution. Okay, so let's look at what this solution looks like. I'll close out for now, but I'm going to go back in just a moment. Maybe I'll just format these numbers a little bit. Bear with me. So the constraint was average quality cannot exceed 1.4, which is exactly what it is. My average years to maturity cannot exceed 5, which is exactly what it is. The total amount is 10 million. I have 3 bonds it's selecting, and my total allocated to municipal is less than 3 million. So this is it. Produces the highest possible earnings given those restrictions. To close this problem off now, what I'm going to do is just load the solver model onto, or save it, onto the worksheet. So I'm going to open it up. I'll say load or save, and then I'm going to tell it where to save it. I didn't really position my worksheet well enough to save it anywhere. I'll put it in W1 and click on save and close. Now, if I needed to load this again, I could. Like if something happened to my model and I were to say like reset all, okay, my solver dialog is now blank. If I didn't have these optimum values here, for example, if these optimum values were blank, my solver model is empty. I can say, well, you know what? Load a model for me. I select the cells where I saved my output from before, and I say load this model right now. And now I'm going to click on solve, and it should give me the same answer it found before. So there we have it. I hope you found this useful. This one was a little bit complicated, so my apologies about that. But if there are any questions, reach out. Take care, everybody.